and take a look at chemistry. Okay, so here's what I got out of the video. Let me see. Oh, I gotta switch to the camera. Hang on. Stop share. Go to the camera. Advanced camera share. All right, so here's what I got. Let me know if this is what you got. Something like it. All right, here's the table I got. And this is the information from the video. If you want to, take a screenshot right now. And then you'll have it all. Or just scribble it real quick. But in that short 10-minute video, here's what they did. This was the first row. And then this was the second row. And the reason she went from the first row to the third row is so that there wouldn't be chemical contamination. So if you were squirting with the barrel pipettes, the transfer pipettes, and it went over to the second well, then it didn't matter because they're further apart. So hopefully that's what happened. Okay, so she started out with lead 2, and lead is Pb. And the Roman numeral 2 means it has a charge of 2+. That's going to be important later. Okay. And so we have lead 2, and then she put 4 drops in each of 4 different wells. Okay. Then she came by and she added an ion. Now this has a plus to it. And so a plus ion is called a cation. And a cation is a positive ion. All right. Similarly, a negative ion is called an anion. The way I remember it is positive cats. If you, that's my mind picture. A cat that's saying, "Good job." A cat that says, "Be positive," like my blood type. Right? That's a cat ion, a positive cat, and that is a positive ion. So right here, this is a positive ion. What happens is that the positive ion in these 4 wells, to that positive ion, negative ions were added. So bromide is actually Br minus, the charge of minus. Now, I think later on in this learning period, we go over why this is a 1 and this is a 2+. And by the way, if it's 2+ like this, you can also write it as Pb++ if you want to. But sometimes that gets cumbersome, so we put numbers in front because sometimes it can be 3 pluses or 4 pluses. Okay, like down here, we have a 3 minus. So instead of putting minus, 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 I put 3 minus. All right, so here's carbonate. Carbonate actually is in, there's a table in your book. Here's my book. All right, there's a table in your book that is on, in your book, the most valuable page is the periodic table of elements, but there's another page, and the periodic table of elements is on page 168, 169. Periodic table. Okay, but the second most famous useful page is another table called the where is it? It's the charges of polyatomic ions. And so I can't even, yeah, let me put this and see. I used to have a post-it on it. What happened? There's another page that's really important, and it has to do with polyatomic ions, and we're in chapter 9 now, right? So probably way up here. Polyatomic ions. Oh, getting closer. Let's see. If you don't know them, on page 281, there's a chart that says naming binary compounds and what the prefixes mean. So that's a good thing to have if you don't know those, but some of them are, you just know because you've been paying attention while you're alive, right? So mono means 1, penta means 5, hexa means 6. Things like that. The other thing is the table of binary names for polyatomic ions and their charges. So I'm looking for that. I think I'm getting closer. I'm on page 278, somewhere around here. It's going to come up. Oh, there it is. Page, and then I'm going to post it. I'll have to do that again. There's the post-it. Page 268 is what I'm talking about. Your whole book, the most important thing is the periodic table. But the second most important page is this thing right here. I know most of these, but I should know most of these. But you probably don't know half of these. So if you see the term nitrite, not nitrite, it's NO2, but nitrate is NO3, and they both have a negative charge. All of these guys right here have a negative charge. All these guys have a double negative charge. We have a 3 minus, and then we have a NH4. These are polyatomic ions. Why don't we have a list for atomic ions? Well, because you can figure it out from the periodic table. You go to the periodic table, right, where'd it go? 168 or something? Go to the periodic table. This row right here, the alkali have a +1 charge. These guys right here, the alkali earths have a +2 charge. Going to the other side, these guys don't have charge. These guys are stable. These guys are the noble gases, but these are very reactive. These have 7 electrons in their outermost shell. And so you want to get to 8. So these guys all need 1 more. So that's a negative right there. These guys have a 1 minus charge. These guys have a 2 minus charge. These guys have a 3 minus charge. How do you get 3? 5 plus 3 is 8. 6 plus 2, 2 minus. 6 plus 2 is 8. 7 plus 1 is 8. These guys all have a -1 charge. This is already at 8. These guys have no charge. Over here, these numbers tell you how many positive charges are. There's 1 positive charge here, 2 positive charges here. Here, it gets a little goofy, so it's not, you don't see that pattern. All right, so that's on page 168, 169, and then if I struggled to find the polyatomic ions, that's on page 268. Okay, so I'm gonna keep it up to 268, but I know these. So the carbonate, oh, where am I? There's the carbonate. Now the carbonate is like carbon dioxide, right? CO, but it's CO3. And carbonate has a 2 minus charge. And so that's carbonate. Hydroxide is OH. So that's OH and has a 1 minus charge. And then sulfate, uh-oh, what happened? Sulfate is SO4. That's sulfur and 4 oxygens. And this whole thing together has a 2 minus charge. All right. So what you saw in the video is that when you added these guys together, nothing seemed to happen. But when you added this together, you had a precipitate. There was a white powdery solid. Okay. Over here, you did it the same thing, except instead of using lead, you used a phosphate. Well, phosphate is a negative. So it's an anion. And so you had a 3 minus charge on the phosphate. And then here you're going to add these, not these guys here, but you're going to add these guys here. And these are all transition metals. So these guys have a different charge. So barium is in that second row. So it's barium 2 plus. Calcium is in that row also. So calcium is also plus or 2 plus. Lead, there are different forms of lead, but this is lead 1 and this one's lead 2. So this was lead 1. And this is silver, and she said she was using silver 1. So that's silver. So when they did this one, what they got was solids in all of them. But this one, these are all white. And when I say P, I mean there's a precipitate. These are all white, all the way across. And on the top, they're all white. On the bottom, they were all white, except for that last one. The last one was yellow. So here's my completed table of what happened. Okay. So now what you gotta do is you gotta go to our page in the book. What page is that? 270, 271. I don't remember. And if I switch screens, I won't be able to see it. Anyone know? It's on page 279. So this is a lab called Making Ionic Compounds. And it's on page 279. Okay, so now that you have this information, you got to be able to go to 279. And we changed up all this stuff, right? So you can disregard this, but the questions are still good. So I need you to think about these things as you work with this material, but then also write an introduction. And if you take the screenshot I made, that can be your materials and methods. And then if you took a screenshot of the table, that could be your data section, right? I'll make it nice and pretty in case you want to do it. There's your screenshot if you want. And then you, for your last section of your lab report, write a discussion where you answer these 4 questions, 1, 2, 3, 4, and you write a concluding paragraph. Okay, so that's where we're headed with that one. Real briefly, I'll give you some clues as to what you're looking for the questions. Number 1 says some ionic compounds are insoluble in water. What did you observe? Well, we saw precipitates in just about every one of them, except for that very first one. How many compounds formed were insoluble? Well, they all were, because insoluble means it doesn't dissolve in water. So that's why they came out of the water. That's why you could see them. And so 7 out of our 8 were insoluble. Oh, I didn't mean to give you that good of an answer. But think about that, okay? All right, the harder parts are 2 and 3. It says write the formula for each ionic compound formed and then name each ionic compound formed. This will make more sense after you read chapter 9. So do chapter 9 sections 1 and 2, and then this will make more sense. Now to write the formula very quickly, here's what you would do. To write the formula for this one, let's see, here's a white precipitate. What's the formula for that? Or what's the name of that? Well, this is lead carbonate. Just to add these together. But when you name something, the cation is first, the anion is second. So the plus is first and the minus is second. So this is lead bromide. This is lead carbonate. This is lead hydroxide. This is lead sulfate. And then over here, this is barium, see it's positive. Barium phosphate is what formed. Calcium phosphate was the white powder. Lead phosphate is that stuff right there. The yellow stuff was silver phosphate. So that's how you name it. But if you have one of these, you got to put it in there. So it's silver 1 phosphate. It's lead 2 bromide, lead 2 carbonate, lead 2 hydroxide, lead 2 sulfate. That's because there are different forms of lead. You can even see them here. Here's lead 2 and here's lead 1. Oh, and I forgot to write. So this one will be lead 1 phosphate. All right, now the hardest part is number 3. So for number 3, let me get some paper. Oh. For number 3, what you have is, now that you've named it, what's the formula for it? Well, okay, so this one is lead 2 bromide. Let's do that as an example. You have lead parentheses 2 bromide. Well, how do we write the formula for that? Well, I gave you the symbols. So there's Pb 2 plus, and bromide is Br minus. But these charges have to balance. So with these charges, what you got to do, and I got to zoom out of the way because it's blocking stuff. Oh, there's a paper's flying all over my desk. Okay, so there's lead 2 bromide, Pb2 plus Br minus. Over here, I only have 1 minus, and here I have 2 pluses. Well, to make those balance, I got to add 2 of these. So if I were going to draw this out, here's a Pb, and the Pb would be connected to 2 Brs. So there's a Br and there's a Br. So 1 Pb and 2 Brs. Well, the subscript tells you how many atoms there are. If there's no subscript, you assume 1. So here's 1. So I don't have to put the subscript there. But I have 2 of these because I need 2 of these because each one is -1. So there's -1, there's -1. And the -1s have to balance the 2 plus. So this is 2 plus, this is minus, this is minus. Now electrically, these are balanced, and the way I write that is by putting right here, I have to put a subscript, I have to put a 2. So the formula for number, in question 3, what's the formula? PbBr2. Once you get the final formula, you don't have to put the electrical things in anymore. So my final answer is PbBr2. And do that for the rest of them. Just make sure they're balanced. So these are a little bit tougher. Let's do calcium phosphate. Calcium phosphate. Now calcium is Ca, and it's 2 plus. And phosphate is PO4. And this whole thing has a 3 minus charge. Uh-oh. Now what? Well, the thing is, what you can do is, all right, lowest common denominator, all right, there. So then you got to work with 6. Okay. Why? Because you can't split those up. So I've got to have 3 of these, because if I have 3 of these, look, I got calcium 2 plus, calcium 2 plus. I got a third calcium 2 plus. Now I have 6 plus charges. Well, if I hook those up to a PO4, and the PO4 is 3 minus, and now that takes care of 3 of the 6 pluses. If I had 1 more, that's PO4 3 minus. Now I have 6 minuses, and I have 6 pluses. So electrically balanced, I have Ca2 plus, PO4 3 minus. I have 1, 2, 3 calciums. I put that in the subscript. And I have 1, 2 phosphates, and I put that there. That's probably the hardest one. I probably should have done a different one. Oh well, calcium phosphate. So that's that one. Okay, so you try to do some more as number 2 and number 3. And I'm going to stop the screen share. And I am going to, let's see, go over here.